Swayam Prabha. Digital India. Educated India.
So please take this up as an exercise and do the analysis before the next lecture. Okay. And to illustrate superposition, you can also try this. In addition to this, let me say I have a current source of value 5 milliamps. Okay, and then you can see you can solve for this one. Okay, again with this calculate the same things. Okay. So these are the exercises. As usual, please go through it. Please go through the circuit step by step and do it while understanding every step. Okay. The analysis of this is very simple, but you should be able to do it with confidence. Okay. Somebody answered saying V1 will be 8 volts. That is not correct. Please do the analysis in detail and then solve for it. Okay. Now let's go to something else. We will prove another theorem based on a substitution theorem, and this is something that is very widely used. Okay, and in fact it will use substitution theorem and superposition. So I am glad you brought up the topic of superposition. Okay. Now let's say we have a circuit N with independent sources and linear elements. Okay. When I say linear elements, it has resistors and controlled sources. Okay, and it can be any network. Right, the connections inside, we are not imposing any condition, so it will have independent sources and linear elements, and linear elements means resistors and control sources. The only condition I will say is all the control sources have controlling quantities inside N. Okay, it's not that any control source is controlled by a voltage that is outside somewhere else. Okay, if it's a voltage controlled source, that voltage will be inside N, and similarly if it's a current controlled source, that current will be inside N. Okay, so that's the only condition I'll impose. Okay, now let's say that a current source Ix is connected to it. It has two terminals. I will call them 1 prime that are coming out, and I have this current source connected up like this 1 to 1 prime. Okay. Is this clear? The definition of the circuit I have. Now the voltage here will be of some form. Okay. Now what I will do is, I will try to solve it by superposition. Superposition means that when I have independent sources, I don't take all of them together. I can take one by one, and I don't have to do it one by one. If I have 10 of them, I don't have to do it 10 times. I can take 5 once and then the remaining 5 the other time, and so on. Okay. Now in this case, how I will split it is, I will do it with only this current source active and everything inside inactive, and then I will make this inactive, the outside current source Ix inactive, and everything inside active. Okay, so that is also valid. So when I say superposition, you don't necessarily have to take it one by one. So if I have let's say inside the circuit, let's say I have 5 independent sources, 2 current sources, and 3 voltage sources. I can do superposition with I1 alone active and all others 0, I2 and V1, V2, V3, and then add up the results. Okay. Instead, I can also do it like this. I can take I1 and I2 and V1 active. Okay. And V2, and in that case I will set V2 and V3 to 0. Next I will take V2 and V3 active and set the rest to 0, and I add up the two results. Okay. So this will give me exactly the same answer. Okay. So just so you don't get confused with this, let me show it with an example. So please try to solve this. So let me take a very simple circuit again. So this is the circuit. Okay. Now first of all, you can solve for this in a number of ways. You can either use nodal analysis or mesh analysis and solve for it. So please do that and let me know the voltage across this 6 kilo ohm resistor. Let me call that V1. Please take this up as an exercise and use nodal analysis to find V1. Okay. So this is an extremely simple example. There are only 2 nodes. In fact, I suggest that you take this as the reference node. There are only 2 nodes in the circuit, and this node has a voltage source connected to the reference node. So this node voltage is already known. So you only have to write one equation, one nodal equation, and solve for V1. So please do that. Please take it as an exercise. And let me know the value of this V1 in this circuit. I hope the question is clear. All I am asking for is this value of V1, and just do it by nodal analysis by writing the KCL equation at this particular node. Okay. I got one response. Anybody else? So I've got 3 responses, all different from each other. So hopefully others also have solved it. Okay, so maybe, or you can just answer it in the poll. Okay, I opened a poll with all the responses that I've got. Please just click on the poll and let me know your answer. Okay, so this is the result of the poll. I mean, somebody has voted for all of these choices, but the point is only one of these can be correct. So I will work it out in detail, and you can figure out for yourself where you went wrong. This is very important because obviously 3 of these answers are incorrect. Now then you can figure out where you went wrong and then fix it for the next time. Okay. Now I said write KCL at this node, and from there calculate V1. So the voltage of this node with respect to the reference node is nothing but V1. Okay. So the current, when we write KCL, the currents flowing out will together be equal to 0. So the current flowing in the 4 kilo ohm resistor that is flowing away from this node will be V1 minus 10 volts divided by 4 kilo ohms, plus the current flowing in the 6 kilo ohm resistor is V1 by 6 kilo ohms, plus the current flowing here, it is a current source, so we know the current flowing in this direction will be minus 1 amperes, 1 minus 1 milliampere, okay, will be equal to 0, right? So V1, if I group all of that together, I will have V1 times 1 by 4 kilo ohm plus 1 by 6 kilo ohm equals 10 volt divided by 4 kilo ohm, okay, plus 1 milliampere, okay. This is what we'll have. So V1 will be uh, 10 volt by 4 kilo ohm, 1 by 1 over 4 kilo ohm plus 1 by 6 kilo ohms plus 1 milliampere divided by 1 by 4 kilo ohm plus 1 by 6 kilo ohms. Okay. So if I take this inside, I will get 10 volt, 1 divided by 4 kilo ohm, this gives me 1, plus 4 by 6, this gives me 2/3. Okay. And this one here, if I calculate this, I will get 6 kilo ohm plus 4 kilo ohms divided by 4 kilo ohm times 6 kilo ohm, okay, which is basically 10 by 24 kilo ohm. In the denominator we have kilo ohm square, in the numerator we have kilo ohm, so we have 10 by 24 kilo ohm. So we have 1 milliamp times 24 kilo ohms divided by 10. Okay. So you can see that this will be 6 volts, that is 10 volts times 3 by 5, plus this will be 1 milliamp times 2.4 kilo ohms, 2.4 volts, which is equal to 8.4 volts. Okay, so the correct answer is 8.4 volts. So I hope it's very clear how to do this. So if you do this nodal analysis, you will get the final answer in one shot. Now let me also do it by superposition just to demonstrate it to you. Okay, so what I will do is I will first set this 10 volts independent source to 0 and find V1 as a result of the 1 milliamp current source, and then I will set this to 0, the 1 milliamp source to 0, and find this V1 as a result of the 10 volt source. And then I add up the values of V1 from this circuit and that circuit, and that will give me the same answer as before, or it should, if superposition is valid. Now this is a linear circuit. We have independent sources, and except the independent sources we have just resistors which are linear. So we can apply superposition. Okay. Now when I set 10 volt source to 0, what does it mean? What should I replace the 10 volt source by? When I say set to 0, what does it mean? What should I replace it by? Okay, so many of you answered that it is replaced by a short circuit. So this is a voltage source. When I make the voltage source a 0 volt source, it is a short circuit. Okay. Okay. So here I have to replace it with a short circuit. Now similarly, when I set the current source to 0, what should I replace by? What should I replace it by? So clearly I have to replace it with a 0 current source, and a 0 current means no current, which is an open circuit. Okay. So there should be no confusion in this. sometimes you hear terms like I remove the sources. Just try not to use that because it will only lead to confusion. So you just make that source value equal to 0. So if it's a voltage source, it becomes a short circuit. If it's a current source, it becomes an open circuit. Okay. So now in the first case, what is the value of V1? If you observe, the 6 kilo ohm and 4 kilo ohm are in parallel. Okay, it's drawn in a strange way, but really this voltage, this terminal is common to the two resistors and this also. Okay, so both the resistors are connected between this node and that node. So that means they are in parallel. Okay, so what I have really is a 1 milliamp current source going into this 4 kilo ohm and 6 kilo ohm in parallel, and we know what happens when you connect resistors in parallel. It is equivalent to a single resistor of value 1 by the reciprocal of the resistors. In fact, when you have only two resistors in parallel, you can use the formula R1 R2 by R1 plus R2. So you will get 4 kilo ohm times 6 kilo ohms divided by 4 kilo ohm plus 6 kilo ohm, and this is 24 kilo ohms divided by 10, which is 2.4 kilo ohms. Okay, and if 1 milliamp current flows through 2.4 kilo ohms, so this milliamp and kilo ohm multiplied will give you volts, so you will get 2.4 volts. And by the way, when you use superposition, you make sure that whatever quantity you have to solve for, you have put that in a consistent direction everywhere. Okay, V1 is the voltage across 6 kilo ohm resistor with the upper terminal positive. It's the same here, and in this case V1 will be here across 6 kilo ohm, and that is equal to 1 milliamp times 2.4 kilo ohm, which is 2.4 volts. Okay, and similarly, if I have this particular case, okay, you can calculate the total current. What is the current flowing here? What is the current flowing in this loop? We have two resistors in series, 4 kilo ohms and 6 kilo ohms. So what is the current flowing here? So some of you have answered just one. Always these are quantities with dimensions, so please always give the units along with the number. And some of you have answered 1 ampere, so please be careful about what you are doing and give me the correct answer. The series combination of 4 and 6 kilo ohms is a single resistor of 4 kilo ohms plus 6 kilo ohms, which is 10 kilo ohms. So we have 10 volts divided by 10 kilo ohms, which gives you 1 milliampere. It's not 1 ampere, and don't try not to give answers like 1 because that's only going to get confusing. So this is 1 milliampere, and this 1 milliampere flows through both of these. So the voltage V1 will be 1 milliamp times 6 kilo ohm, which is equal to 6 volts. Okay, so it's very simple. And alternatively, you can recognize that this is a voltage divider and use the voltage divider formula. The voltage across the 6 kilo ohm resistor is nothing but 6 kilo ohm divided by 6 kilo ohm plus 4 kilo ohm times the applied voltage source, which is 10 volts, which gives you 6 volts. Either way, you get the voltage across the 6 kilo ohm resistor to be 6 volts. Okay, so here we have 2.4 volts and here we have 6 volts. Okay, so the actual total voltage will be the sum of these two, which is nothing but 8.4 volts, and it's exactly the same as what we have here, 8.4 volts. Okay, In fact, the way I have written out the expressions, this is the contribution from the voltage source and this is the contribution from the current source, and they get added together. Now, in general, if you have multiple inputs, that is multiple independent sources, okay, you have any voltage or any current in the circuit will be a linear combination of all the sources. Okay, for instance, let me make these variables just for illustration. Let me call this Vs and let me call this Is. If I write Kirchhoff's current law at this node, this part will be exactly the same. Okay, let me, so instead of 10 volts, I will have Vs here, and instead of minus 1 milliampere, I will have minus Is. Okay. So if I take it to that other equation, I will end up getting, instead of 10 volts, I will have Vs, and instead of this 1 milliamp, I will have Is. Okay. So here I will have Vs and there I will have Is. The reason I did that is to just show that this V1 will be some linear combination of Vs and Is. It will be some number times Vs plus some other number times Is. Okay. And if you have many sources, it will always be like this. It will be in a linear combination form, and it's not only V1. You take the voltage or current in any part of the circuit, it will be a linear combination of all the independent sources applied to the circuit. Okay. So in this particular case, we will get V1 to be 0.6 times Vs plus 2.4 kilo ohms times Is. Okay. So if you substitute Vs equal to 10 volt and Is equal to 1 milliamp, you will get the total to be 8.4 volts. Okay. So hopefully this is clear, both how to solve circuits like this. This is a very simple circuit, and also the general idea of superposition. Okay. So we solved the circuit with all the sources in one shot, and then we did it with one source by one source, setting all the other sources to 0, and we got the same answer as we should have got, as we expected from a linear circuit. And we also showed here that any voltage or current will appear as a linear combination of all the independent sources. Okay. So that's what superposition is. So that's how we solve for it. Okay. So now in this case we had only two sources. If we had more than two, if we had three sources, we could have taken two sources at a time and another source, or we could have taken one source at a time 3 times and so on. Okay. So now let's get back to what we were trying to do. We have a network N with many independent sources and linear elements. Linear elements means resistors and linear control sources, and the only condition is that all the controlling quantities are inside this network N. Okay. And there are two terminals that are coming out that are visible to the outside world, 1 and 1 prime, and I connect a current source Ix from 1 to 1 prime. Okay. So to find this voltage across 1 1 prime, let me call this Vx. What I can do is many things. I can solve the entire circuit, but here I am trying to do a particular I am trying to prove a particular circuit theorem. So I will do it in this way. I will take Ix alone, okay, and find Vx. That is, when I say Ix alone, all the independent sources inside are set to 0, and I will set Ix to 0 and use only the independent sources inside. I activate them and find this Vx, and then I can add up the two results and find the total value. Okay. So let me just do that. Let me draw the picture corresponding to that, and we can end this lecture and continue from here in the next lecture. So first what I will do is, So inside the independent sources will be active, and I'll set Ix to 0. Okay. So when I set Ix to 0, what happens? This is an open circuit. Okay. And in the next case, this Ix will be active, and this independent sources, any number of independent sources inside will all be set to 0. Okay. And this is known as nulling the circuit. So I have nulled the network N. That means any independent sources I have set to 0, but Ix is active. Okay. So I will get, let's say I call this Vx1 when Ix is inactive, and this Vx2 when Ix is active, and then I add up the two values of Vx to get the final value. Okay. So this will continue in the next lecture. In fact, you can take this also as an exercise and find the general form of the solution that you get for Vx1 and in particular for Vx2. Okay, what will be the form of Vx2? What will it be? What will be its dependence on Ix? Okay, and we'll take it from there in the next lecture. If there are any questions regarding whatever we discussed today or anything else, please let me know. I'll clear those and end the lecture. So there are several questions. One is asking, is pushing of voltage sources through a node a new theorem? I'm not sure what it is, what is meant by this. I mean, certainly I didn't invent this. It's a well-known result, okay, and a relatively obvious result that is sometimes useful. And the next thing is about current division. Now, current division is the counterpart of voltage division. I will show it with two resistors, R1 and R2. Clearly, if you have two parallel resistors R1, R2, the voltage across them will be the same. Let me call it Vx, and the current through this will be Vx by R1. Here it will be Vx by R2, and by applying KCL at this node, we know that Vx by R1 plus Vx by R2 equals, let me call this Is. Okay, so Vx will be Is divided by 1 by R1 plus 1 by R2, which is Is times R1 R2 by R1 plus R2. I could have written down this directly by noticing that R1 and R2 are in parallel. So Is times R1 parallel R2 is the voltage Vx. Now if I look at any particular current, let's say current flowing through R1, that will be equal to Vx divided by R1. Okay, so this current IR1 is Vx divided by R1, which is equal to Is, and R1 cancels here, R2 by R1 plus R2. And this is analogous to the voltage divider formula. If I have Vs, the voltage across this is Vs R2 by R1 plus R2. Okay. Now it's some ratio of resistors in both cases. In case of current division, the current through R1 will have R2 in the numerator, and in case of voltage division, the voltage across R2 will have R2 in the numerator. That's all. Okay. Now the next question is, actually the question is not clear. I guess the question is what to do with dependent sources when you apply superposition. You don't do anything. You certainly do not set dependent sources to 0. Dependent sources will have whatever dependence they have. Okay. For instance, a voltage controlled voltage source will be dependent on some voltage Vx. Okay. And let's say it is some k times Vx. You don't change anything here. You simply do the analysis as usual. Okay. So if this is Vx, that is k times Vx. Okay. And someone asked for the slide showing superposition. Yeah. So it's here. All that is saying is the source vector, which has many elements, can be thought of as sum of one element at a time. I1 here, I2 here, and V1 there. And there could have been more things. I have not shown it. And you see that this basically comes from linearity, right? So if you have these vectors, you can show it as sum of this one and that one and that one. And G inverse times this is G inverse times that plus G inverse times that plus G inverse times that. And you can interpret each of them as solution when only one of the sources is active. Okay. So I hope that clears up all of those things. Then if you have any other questions, please do feel free to raise them in the forum or in the next lecture. Okay. Thanks for attending. I'll see you on Tuesday.